statistical cracking mode in bypass works different than the other techniques. Instead of using lists of already found passwords or dictionaries that are mangled with rules to generate guesses, it analyzes the passwords that the other modes have already found and figures out what the patterns are that make up those passwords. The patterns can be things like how many digits are on the end of a word, whether it's lower or uppercase, how many letters in a row, etc. We can simulate what bypass is doing by running the pass time program manually. If we take a look at the repository that John has, we'll see that when it stores the password, it stores it in a format of hash, colon, and then the actual password itself. And this so-called pot file contains these patterns. We can cut these apart using the cut command with the delimiter of that colon. And this command looks like this. The delimiter is colon, and we want to take the field 2 or F2. We're just going to send that off into a file called temp passwords. After we do that, if we look at the file temp passwords, we'll see that it contains just those passwords without the hash that preceded it before. Now we can run the pass time program, and we're going to do that on the temp passwords file. So we'll run the pass time program with a percentile of just 50%. The percentage is how many passwords are represented by the set of masks shown. Even though for a large set of passwords like the 200,000 that we have in the temp passwords right now, there's still only going to be a very few masks that represent most of the passwords. Generally speaking, passwords by and large all have the same basic pattern. We use -v for verbose and -l to list the masks and -a to do the analysis. So if we look at the analysis, we can see that the first mask represents 27% of the passwords. It's basically 6 uppercase letters in a row. And 5 uppercase letters in a row adds another 10% for a total of 38%. Followed by some more uppercase letters and then uppercase letters with 2 digits on the end. And that's all the masks that are needed to get to 50%. Even if we raise this to 75%, we'll see that relatively few masks are needed still. Only 11 masks represent the patterns of 75% of the passwords in the repository. And this is actually out of around 1,000 different patterns, unique patterns within those 200,000 passwords. In fact, we can see here that it's exactly 1,086 masks needed to represent 100% of the passwords, but only 11 masks for 75%. And this chart shows a typical story of any password set, where just a few masks represent a whole lot of percent of the passwords, and it drops off very rapidly. So with this information, we'll go ahead and run bypass in the statistical analysis mode. We're going to continue to use the same file that we've been using. There's only a couple of modifications to the command line. We stick with -v for verbose, pass in the fork command using -j, so we'll pass that straight over to John. F is the format of raw MD5, and we're going to use -t0 to suppress bypass's usual behavior of trying to crack passwords first in order to put some into the pot file for the statistical analysis to work. But in our case, we've already run -t options 1, 2, 3, and 4 and the base words mode in order to populate the pot file. -s is for statistical crack and -p of 50%, which is going to account for those 4 masks that we saw earlier. You can change this to 75, even 90%, and you still won't be using a whole lot of masks. It's not very efficient to increase it much more than that, though, because you start to get to the point to where you're finding passwords that have very unique patterns. That's best left to the other modes. So we'll go ahead and run this mode. At first, bypass is going to use pass time to parse those passwords out of the pot file and then generate the masks and do the other calculations needed to get the program set up. Once the processing of the masks are complete, it'll start with the password cracking. We can see here that it found the mask required for 50%, and it started out with the first mask, which is 6 uppercase letters in a row. So it uses the 6-character words dictionary with the rule uppercase, and then starts to apply the cracking with that set. It'll then move on to the next mask. In this case, down here it's running the uppercase 4-character words followed by 2 digits, and so on. This is fairly effective. We're starting to get around 15,000 words. Here we have 1,200. This mode got 1,600, and so on. So it's a fairly effective technique. In the end, we spent about 5 minutes total in the process, and we were able to crack about 18,000 words, about 60 words per second. So this technique is a good supplemental technique to the main techniques of using password lists and also dictionaries with rule mangling, which are going to do well against the low-hanging fruit. The statistical cracking mode can go a step further and get some words that fit the pattern but are not common dictionary words necessarily, or at least they're not common patterns that would normally be seen in existing password lists.